Yes. Hey guys, so we are live. Welcome to this LinkedIn live session where we are going to talk about the hottest topic that everybody is talking about today in the Gen AI space. That's about building production ready RAG pipelines. My name is Pavan Belagatti, and I'm a Gen AI evangelist and the host of this session. Every company today wants to build robust and efficient RAG pipelines. But since a RAG will have many moving parts, it becomes very difficult to build an efficient RAG pipeline. But not to worry, today in this session, our guest, Chris Latimer, will talk about how to build production ready RAG pipelines in minutes. And he will also show that practically through a simple demo. So let me introduce our guest today, Chris. Chris is the founder of Vectorize.io, where he helps companies connect their unstructured data to their LLMs. Before that, Chris led product management for API Gateway at Google and was the general manager of the vector database business at DataStax. And Chris currently lives near Denver, Colorado, with his wife and three daughters. Hi, Chris. Welcome to this live session.
Hey, Pavan, excited to be here. Hello, everybody in the audience today.
Cool. So, first of all, we all know RAG is the cool kid in the Gen AI space. So, first of all, can you just let us know what is this RAG? What is retrieval augmented generation is all about?
Yeah, absolutely. So, RAG started off probably 4 years ago now. I think the term was first coined by some folks at Facebook, if I remember correctly, that were kind of digging into this. And one of the challenges that people, it became evident to sort of the early adopters that large language models were going to be something really useful to a lot of people. And with large language models came challenges because they aren't trained on your data. There's a lot of things that they don't know about. So if you want to ask them questions about, the history of World War II, things that are in Wikipedia, it's going to do a great job of answering those questions. But if you want to be able to get answers to things like, what has your customers been up to? If you want to get information about your product catalog, if you want to get information about your return policy, if you are a customer on a retailer website, those are things where you need to help the LLM to get that context. And so this pattern has emerged that we call retrieval augmented generation. And the way that that works, and let's maybe pull up a quick graphic here, is that
Yeah.
there are a few components. So um, and actually, as the name suggests, RAG or retrieval augmented generation is going to have multiple steps to it. So instead of you just a user asking a question, going to the LLM, seeing what the LLM generates and coming back, what we do is we say, let's help the LLM fill in those knowledge gaps that it has. And so when the user asks a question, we need to retrieve the relevant context. That's the retrieval and retrieval augmented generation. And then when you ask the LLM to do the generation, we say, let's augment your knowledge with this context that we've retrieved. And so it's essentially a way to allow large language models to answer questions or generate content about topics that it was never trained on, which is actually turns out to be a very useful pattern that's being employed now by just about everybody that's doing anything with Gen AI.
Nice, really interesting. So basically, to reduce the hallucinating behavior of large language models and to get the contextually relevant responses back to the user.
That's exactly right. Yeah.
Nice. So, yeah, I mean, can you also explain to our audience about the evolution of RAG over time? Because we heard, AI from the beginning, but recently we started hearing more about RAG. So, how it evolved over time?
Yeah, yeah, absolutely. And maybe I'll contextualize this a bit with a bit of my backstory here in terms of how we came to create Vectorize. So I was working at DataStax at the time, and I was running the vector database business there, and that essentially meant that if anybody had a Gen AI application they were trying to build, I needed to figure out how to help them get that into production. So one of the first things that I realized is that the vector database solves part of that problem, but it doesn't solve your entire problem. There's a lot of things that sort of lead up to a lot of work goes into building a RAG application that actually gives you back relevant results, that cuts down on hallucinations, that performs the way you want it to perform. And so if we go back to sort of your answering your question, that evolution of RAG, I think it started off with what we call naive RAG, which is just let's take a bunch of documents that we have. They could be PDFs, they could be Word docs, they could be things from a knowledge base. Let's get the context and push those into a vector database. So we'll just chunk them up using fixed window size or paragraph chunking or whatever worked best for you. Stick those into your vector database and then do what's called an approximate nearest neighbor search. It's a semantic search. So it's a way for you to find context that's the most similar in meaning. So if you take something like, let's look at two sentences, right, from a keyword search perspective versus a semantic search perspective. So take the sentence, I love being near you and I hate being apart from you, right? So from a keyword perspective, we say these are very different. This is, love and hate are opposites, near and apart are opposites. So those are kind of things that are very different. But from a semantic perspective, if we look at those and say, well, wait, I love being near you and I hate being apart from you, those actually mean the same thing. So that's one of the interesting things that vector databases allow you to do. And so people started to use semantic search more and more to retrieve that context for RAG. And all they would do is they'd take their docs, they'd chunk it up, they'd stick it in the vector database, and then they would do a nearest neighbor search or a semantic search to get back that context based on what the user had asked. And that gets you okay results. I mean, they'll get you back something, right? But what a lot of people found is that I'm still not getting back the relevant information that I wanted. So this has kind of led us into more advanced RAG techniques. I think sort of the state of the art where we are right now is sort of the latest that came out from Anthropic not too long ago, talking about sort of how they are using additional context when they insert their chunks into the vector database. So instead of just saying, hey, here's the example they used in their paper were SEC filings. And so instead of just saying, here's my SEC filing for my quarterly report, for my annual report, and let me chunk it up by paragraph. Instead, what they would do is they would preface those chunks to say, in the company's, in Apple's last quarterly report, in a section titled cash flows, I found this. And that additional context that you layer on top of the chunks allows the LLM to contextualize the information. It gets better. There have been other techniques that have come out as well. There have been things like HIDE, which is short for hypothetical document embedding. This tries to solve the problem in information retrieval. Sometimes this is called asymmetric question answering, which just means that the question that you're asking is semantically different than the answer you're going to retrieve back. So if you think about semantic search, one of the challenges you have to cope with RAG is that when let's say that you take a question a user asked in a chat-like interface, when you do a semantic search against that question, you're going to get back context that's most similar to the question. And sometimes that's going to give you the LLM enough context to answer the question. But what you really would like is you'd like to find the most useful information to answer the question, not just things that are similar to the question itself. And so that's where these techniques like HIDE became popular for a while. Turns out that HIDE in the real world has not seen quite the performance boost that we thought. So what's really interesting with RAG, I think, is all the new techniques that are kind of coming out, and people are discovering better ways to do it. I think we're seeing things like metadata becoming more important. We're seeing this context added to the chunks becoming more important. We look at things like query rewriting. So especially if you have like large chat histories, right? Like what do you actually send to the vector database to retrieve that context? That's where query rewriting can help you sort of figure out what's the right piece of this. How do I rephrase the user's question to get back semantically similar information? So we've seen a lot of advancements and people experimenting and a lot of sort of anecdotal evidence, and I'd say less that's like empirical evidence to say what is the best technique. And I think that's
Hmm.
something a lot of people still struggle with quite a bit.
Yeah, true. And now I see many people are talking about agentic RAG.
Oh, absolutely.
Yeah,
Yeah. 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 I'm one of them.
yeah.
Yeah, we wrote a piece recently on agentic RAG, and I kind of walked
I
through.
saw that.
Did you?
It
Yeah.
went viral. Yeah.
Yeah. Yeah. It was, it was a fun post to write. A lot of good feedback on that. Um, and it really was just the process we had to go through to get agentic RAG to work right, to get this, with agentic AI in general. The idea here is that you are giving your AI agency. You're saying, here's a task I want you to perform. I'm not going to tell you exactly how to perform, and I'm not going to give you a step-by-step algorithm the way I would with procedural programming languages. Instead, I'm going to say, LLM, you have artificial intelligence, use that intelligence to reason your way through solving this problem. And by the way, here's the set of tools you have to interact with the outside world. And oftentimes these are things that come into play, like retriever functions, where RAG plays a big role in agentic use cases, because you need to be able to retrieve the context that's
True.
going to help the LLM figure out how to go about solving the problem that you've asked it to solve. That could be a problem like customer service. I'm actually writing a post right now talking about a use case with a retailer we worked with, where one of the use cases was returns. So, like, what's your return policy? I need to do a semantic search and find the return policy. And then I need to
Hmm.
figure out, like, am I within the window? So I need to do a retrieval to figure out when the order was placed. So all these things kind of come together to allow AI to take on more and more complex tasks.
Right. So looks like we have come I don't say long way since RAG is kind of also new for a lot of the folks there, like NavRag to um, what is that, advanced RAG
Mm-hmm.
to using re-ranking and all that,
Yeah.
and then to agentic RAG to multimodal RAG, what we
Multimodal is
see.
another big one. Yeah.
Yeah.
Yeah, and I think what's nice about sort of folks that are getting just starting their first project with RAG at this point, and just like building their first Gen AI applications. Even just a year ago,
Hmm.
there was not a lot of patterns to rely on. There was a lot of guessing, right? And nobody quite knew. They were
Right.
like, I don't know, I'm going to try something, I'm going to see how it works. And now what we're
Right.
seeing is we're starting to see some of these patterns emerge, especially around, multimodal RAG is one where I think we're starting to see
Right.
patterns emerge around, do I take the sort of non-text modalities, and do I store those in the vector database? Do I put those in as metadata, base 64 encode images, for example? Do I store a pointer to those images? Do I use
Mm.
image to text, right? So there's all these interesting techniques that are coming out, that are allowing people to build these applications a little bit faster and more reliably, and take advantages of the lessons that we've learned over the past 18 to 24 months, that people have been working on these type of applications in a very concerted effort.
True. True. Yeah, since we are talking about the hero here, RAG, so how do you see, like, how's RAG is more superior to the other two techniques that usually people talk about, like prompt engineering and fine tuning?
Yeah, well, I think all three of these things can coexist together in the right circumstances, and you
Hmm.
need to reach for the right tool for the right to solve the right problem. I'll say you're always going to use prompt engineering, in my opinion. So it's
Yeah.
obviously it's the easiest thing to do. You just change what you type into the LLM, and I think for some things you can get fairly far. There are certain problems that RAG won't necessarily help you solve. Uh,
Hmm.
uh, if you look at say fine tuning, one of the big problems that you have with fine tuning is, we've seen these jailbreaking prompts, right? That they get the LLMs to either do things they weren't supposed to, or more concerningly for enterprises, leak out the training data. And so there was a kind of a famous one, probably a year or more ago now, where I think it was the one of the teams at Google, I believe, just asked ChatGPT, like, "Hey, just keep repeating this word, repeat the same word over and over again." And after it repeated the word, I'm kind of making up the number here, 10,000 times, whatever that number of times was. All of a sudden, it just started to leak out, like, all this information that had been trained on. And so you can imagine if you had decided, hey, I'm not going to use RAG, I'm going to use fine tuning, and I'm going to fine tune this with, personal data for my customers. It's like, oh my gosh, well, that's leaking out now. So most people, I think, are sensible enough to say, you know what, we're never going to fine tune our model with personal
Mm,
information.
right.
And I'm going to be very careful about fine tuning models, even if I host the model, even if that model is something where it's not OpenAI's model, it's not on Vertex, I'm running, Llama 3 locally and on GPUs. You still want to be very careful with sort of like assume that at some point in time that data, somebody's going to figure out a way to get that data out of the model. Um,
Right.
so then, what do you want to use fine tuning for? You want to use fine tuning when you've got, a specific way you want the LLM to respond to, to an answer like over time, different stylistic choices, different techniques that, situations where you don't need to sort of have context, especially up-to-date context. The nice thing with
Mm,
RAG is it's going to give you the data that is most relevant and usually the data that's most timely, right? So with RAG, it's
right.
very easy for us to say, hey, let's look up the order that the user placed 5 minutes ago. Whereas fine tuning, that's really not a viable option. And then prompt engineering, I think, just is cross-cutting. I think you're always going to use prompt engineering across all these things. You can use prompt engineering with a fine-tuned model. You can use prompt engineering with RAG. You can use prompt engineering with RAG on a fine-tuned model. So like all these things come
Mm,
together, right, to
mm,
figure out like how you build a solution that's going to work
right.
best for your use case.
Right. And also, I see like fine tuning requires a lot of effort and computation power, is what.
To get good results, yeah. I mean, I mean, generally you're giving, you're tuning the model with some type of question answer set that you've built up. Now, if you have things where you just by virtue of, maybe you have a support use case and you've asked and answered a lot of questions about your product on Intercom or on, Slack or on wherever, and you can pull that data out and fine tune a model, then, it may not require that much effort. Maybe you could just push it right in. But if you're trying to fine tune a model from scratch, yeah, I mean, it can be effort intensive for sure, especially compared to RAG. RAG is so easy. You just grab grab the data that you want and push it in. Now, all the work that goes before, building out the search indexes is not necessarily easy, but once you have that
Mhm.
built up,
Yeah,
right from that point, it's pretty straightforward to implement.
true, true. So, what do you think? What are some parameters to look for while building a proper rack pipeline, efficient rack pipeline? What do you think?
Yeah, well, I think this is one of the things that I kept seeing over and over, when I was working with customers before, starting Vectorize, is that we'd get all the way to the end of these projects. So we'd figure out like where the docs were coming from. We would load the vector database. We'd build the interface for this application, and then you would push it into production to like an initial set of users, and they'd come back and they'd say like, hey, this doesn't work very well. I'm getting back wrong answers. It's getting back stale answers. I'm getting back sort of things that are not optimal for how I would expect this. A lot of this were these conversational AIs to work. And so that led us to build out, that led us to really start thinking about RAG evaluation. And in fact, maybe I'll kind of we can show an example of this coming up too when we get to the
Yeah,
demo.
sure.
But, this led us to start thinking a lot about, RAG evaluation. How could we figure out the best way to vectorize data so that you get back relevant results from your search indexes? And so the ones that we rely most heavily on, there are two. So we use context relevancy. And so context relevancy is a feature that's baked into the re-ranking model that we use. And what that essentially does is it allows us to take a set of documents, generate synthetic questions for those documents, and then
Mhm.
build out uh, different indexes in parallel. So then we can
Okay.
look and say, okay, let's tweak the embedding model. Let's tweak the chunk size. Let's tweak the top K that we use. Let's tweak the overlap that we use. And then what we can do there is we can look and say, more empirically now, what's going to give us the best results. And so we use the context relevancy. We also combine that with NDCG, which stands for normalized discounted cumulative gain, which is just
Hmm.
a way to decide, a way to analyze the ordering of the results that come back from a vector database to say, did these come back with the most relevant result first and the least relevant result of the top K that we retrieved in order? And so if it does, it comes back perfectly in order, you get a NDCG of 1. If it comes back, the complete opposite order, it's going to be an NDCG of 0. And so it's going to give you sort of this blended score as to how relevant the results are and how good your vector database and your embedding model were at returning back the results in the right order.
Okay, nice. So we talked a lot about RAG, and now I would like to understand more about how Vectorize is helping companies build perfect production-ready RAG pipelines.
Yeah, so I mean, what we try to do, at Vectorize, we try to take the guesswork out of RAG. So if you think
Mhm.
about the typical process that a developer goes through, an AI engineer goes through to build out a well-performing vector index, there's usually some type of experimentation. You're going to pick something. You'll pick OpenAI, or you'll pick Voyage AI, or one of the embedding models off of Bedrock, and you take that, you chunk your data up, and you stick it into the vector database. And you don't really know. And actually, this is kind of a unique aspect of vector data. Let's imagine you were doing data engineering from Postgres into Snowflake. Well, you know what the data looks like in Postgres, and you know what the data should look like in Snowflake. And so you can write tests. You can know for sure, did my data pipeline work correctly? Is the data in the structure that I want? Did customer underscore ID get translated into customer ID over here? And so it's very deterministic. But when you're dealing with vector data, you just know that you've got some documents or some sort of unstructured data as a source, and at the destination, you're going to get some type of vector. Well, the
Mm.
vector is just a long list of floating point numbers. So how do you know
Right.
if that's a good vector or a bad vector, if that's going to work well until you actually connect it to your LLM? So what we try to do at Vectorize is say, let's take a data-driven approach. So instead of you as an AI engineer going and writing some Python scripts, chunking up your docs, picking an embedding model, picking a chunking strategy, and then trying to just sort of gut feel your way through, like, did this work well? Like, am I getting results that are better with, the V3 small model versus the V3 large model? What we do is we say, hey, let's just get a data-driven approach, and we're going to give you in just a couple of minutes, like, quantitative data that you can base this decision on. Is the
Mm.
actual results that you're getting back, are they more relevant? Are you getting, and there's a cost component here too. Like, bigger vectors, cost more to store. They're more compute intensive. So are you getting sort of like maybe V3 large is a little better, but is it better enough that
Right.
it's worth the cost? So
Mm.
we try to give you that picture very clearly up front. And then we give you RAG pipelines. So our RAG pipelines are production ready pipelines, which, as the name of our LinkedIn Live here suggests, is important, because building, just sort of like getting the data into your vector database,
True.
is not the end game, right? Like, there's a lot of things that could go wrong with your pipeline.
Right.
OpenAI's APIs will return errors sometimes, just like everybody's API returns errors sometimes. Your vector database may become unreachable. Your source system may become unreachable. So we really have built Vectorize to on top of a very solid data engineering platform. So we use a system called Apache Pulsar. It's built to have very reliable message delivery guarantees. So
Mhm.
whenever we find a change in one of your a piece of data, that gets written to two different ledger nodes. So we use a distributed ledger for that storage. So if something at that point, once we've acknowledged the message, if you lose a node, if you lose a data center, it'll be delayed processing, but it will get processed. So we build very high reliability data pipelines. And then we have connectors. We have connectors to a lot of different things: Google Drive, SharePoint, web crawlers, Firecrawl,
Mhm.
across the board, S3, GCS, lots of different connectors. So we make it easy for you to take that data, figure out what's going to work best for that data, get it into your vector database like SingleStore, and then keep it updated. Because one of the biggest things we would see folks struggle with is that you would go through this whole process. You'd figure out, how do I vectorize my data, finally get it to the point where it works right. And as soon as you populate that vector database, it immediately starts going stale. So like, your
Right.
source systems change, and now it's like, well, wait, now what, how often do I need to update this? So we also give
Correct.
you a way to keep that up to date in real time. If you want to update it periodically, we give you that as well. And so we really take, I mean, the way I think about it is that we reduce the time it takes for you to build a RAG application that's production ready by around 80 to 90%.
Nice. So can we see that, the
Yeah,
demo?
yeah, absolutely.
Yeah.
Let's take a look. And then, folks that are asking questions, if there's time, we'll circle back at the end, answer
Yeah.
your questions. But yeah, but let me jump in here really quick, and I'm just going to get a couple things
So
right.
people can go to vectorize.io to sign up and then they can get started easily.
Yeah, that's correct. Yeah, if you go to vectorize.io, you'll see that there is this start, try now, try free now, start for free now. Any of these buttons are going to take you to platform.vectorize.io, go through, sign up with Google or an email, whatever you prefer. And yeah, you'll have an organization in no time. There's a free tier, so you can start for free. If you start using a lot of pipeline hours, then you can jump into our starter tier. But it's made for developers to be able to build a real application for free if they want to. And so let me start here, because this is the piece I was describing a few minutes ago. This is the RAG evaluation piece. And so you can't see it off screen, but I'm going to drag a few files into this drag and drop area here. And so I've given this a few archive papers. So these are papers about RAG. This is corrective RAG and self-RAG and other techniques that people are using. And I'll just give this a name like RAG papers. I'm going to use custom here so we can see the knobs and dials that you can use to tweak your evaluation. You can pick the database engine that you want to use here. And then we give you the ability to select different embedding models that you want to try. You can tweak the settings on, on things here. We have different extractors that this is actually not quite turned on for everybody yet. You'll just see fast if you come in here. We're working on some new things that will be pretty exciting in the coming weeks that'll enhance this and make this even better. And then as you have selected the settings that you want to use for your evaluation, you click Create RAG Evaluation. This is going to kick off a process that's going to do a few things. So the first thing it's going to do is that we're going to take the contents of those files. We do an extraction step. And so we pull out all the text, and we use that in two ways. The first is that we populate these vector indexes that you see on the screen here. So vector index 1, 2, 3, and 4. These are all getting populated now in real time into our vector database. And then as that's happening, we're also generating these synthetic questions that you see here at the bottom. So we've taken the context, we have a finely tuned model, we look and say, let's generate questions that are kind of broad in nature that these documents would be good at answering. So the first thing that you'll see is if these questions aren't in line with the things that you expect your users to ask, then you kind of have a data gap here. And no matter what we do, we can't fix the problem. There's the wrong data. So then you may have to reevaluate your data. But assuming you look at these questions and say, yeah, these are in line. These are the types of questions that people would have about large language model question answering systems or RAG model components or whatever your documents are. Then what you'll see is that as we populate these vector indexes, we start to score them after a moment. And the scoring process here will take each one of the questions that we ask, and it will do a retrieval against this index, this index, this index, this index, so on and so forth, until we go through the entire list. And then as we go through that entire list, you'll see the scoring will start to happen here. So we'll go through the scores, we'll do the retrieval, and then here are those metrics that I mentioned earlier. We have the relevancy score. This tells us how relevant the context that came back from the vector database was. And then we'll have this NDCG score, which will tell us, did we get back the most relevant answer first and the least relevant of the answers that came back, or the chunks that came back from the vector database at the end. And then based on this, we assign a winner. And so the winner here is our OpenAI v3 large. You've got now data to go on, but you don't have to take our word for it. You can come in here into the RAG sandbox. And the RAG sandbox is this end-to-end testing tool. You'll see all of the, let me make that a little bigger. You'll see all of the synthetic questions that we generated here. You can, play around with these until you find ones that you like. And you can also just ask your own question. If there's something you wanted to know, you can type in here. Over here, you'll see exactly what came back from the vector database. You'll see, in this case, I'm using LLMs powered by Grok. And you'll see the in generation that the language model used once you gave it the context and you gave it the question and you injected that question into your prompt. You can play around here with prompt engineering if you want to as well. And so this gives you now sort of a way to get both quantitative data that we saw before on that graph, as well as qualitative data. And you can now make your own assessment. Do I agree with the results that I'm seeing here from the data? And so, if you look here, we did this now with 4 different vector indexes. You as an AI engineer, if you were to do this yourself, depending on how thorough you were, if you were like really fast and sort of dirty and just kind of, doing a gut feel check, populating each one of these is still a few hours worth of work. If you're doing something that's like, if you were trying to build out the same level of, quantitative assessment, this is probably more like a day or two's work for each one of these to build those out, and then to sort of compare the results together. This is easily like, this is easily the better part of a week's worth of work for an AI engineer to get to the same level of results. We give it to you in, how long have we been going? Like maybe 5 minutes at the most.
Yep. Cool. So yeah.
Yes, this is the eval. The idea here, right? This is kind of like where you would start your development process and say, let me start off by figuring out how do I vectorize the data in the best way. And then, of course, this is a sample of your docs, right? This isn't sort of the be all end all. I've now connected all the data that I want. And so now what you likely want to do is you want to build a RAG pipeline. And so here on the RAG pipeline, the idea here is to say, now let's do this for real. Let's connect the data we just saw before. That's all running in sort of a vectorized vector database behind the scenes. Like we use SingleStore, we use Pinecone, and the others that you saw there. This is to say, let's use your database. Let's populate your real vector database with your real data. And so I'll show you how that works quickly. Here, we'll just make a pipeline called docs. I've already got a SingleStore instance set up. If you are familiar with SingleStore, this is all going to look really familiar to you. The same parameters you would pass in to connect to your SingleStore instance, you would specify those in your config. Like I said, I've already set one up here. Let's call this VIO docs for Vectorize IO docs. I don't know if I can have a dash in there. I'll just use the OpenAI model. It looked like the V3 large worked a little bit better in our example. And now you select your source connector. So like I mentioned, we've got source connectors to lots of different things here, ranging from file storage to web crawlers. I'll use our built-in web crawler. And I'm just going to point to the Vectorize documentation, accept all the defaults here. And then here's one of the nice things with Vectorize is that you can configure how often you want to update your pipeline. So if you have things that don't change particularly often, maybe this is going to be fine. You'll say, just update this weekly, every Monday, come in, run this pipeline, we're going to be good to go. But you may have things that are changing much more often. You'd say, let's use a real-time pipeline. I want this thing to run 24/7. As soon as the change comes in, I want to get it, process it, and update my vector database, all the way down to manual, where you say, look, just run it one time for me, and I'm good, and I'm done. And if I want to update it again, I'll come back and I'll kick off my pipeline again to grab the updates. And then as we do this, as we deploy this, you'll see that the behind the scene, what we're doing is we're deploying all the infrastructure I mentioned before. So we're spinning up different topics behind the scenes. We're spinning up different ledgers behind the scenes. And we're creating all of the infrastructure that's required for us to handle the processing that we just defined. So there's a connector that's spinning up that's our web crawler. That web crawler will go out and start crawling the website that we pushed out there. We spun up the connector to the vector database engine, and so now that's being deployed. We have health checks that are running, and so on this next screen that'll pop up here in a second, you'll see that we'll give you sort of like real-time views here into, how is our connectivity to SingleStore? Is our web crawler healthy? Is our OpenAI connection healthy? Is the key working? And if something ever goes, incorrectly, we would see that down here as we go. And then here in a minute, table VIO docs was created. Yeah, here in a minute, what we'll see is the web crawler is going to start to discover those pages in our documentation. And then as it does, it's going to immediately start start populating the vector database. We'll get visibility here into the pages that have been processed as well as the ones that were skipped. So I kind of glanced over it, but you have configuration on that web crawler to say, what domains do I want to crawl? If I only want to crawl URLs that I find that are on that domain, that's kind of the default. And we'll see here we skipped 10. Why did we skip those 10? Well, those 10 were outside they were outside of the configuration. And so the connector said, oh, I'm not supposed to crawl those. It won't crawl those. And we'll see this right away, this process in real time. The other thing that we'll see if we come over here is that we get that same RAG sandbox experience that we saw with the evaluation. So I can come in here and ask a question like, does Vectorize support SingleStore? And then based on that, we'll also here see the results that come back from the vector database, see the relevancy of the context that comes back from the vector database, and then we'll see how the language model that we're using generated its response with that context in mind. And so here in this case, we see what we got back is the SingleStore documentation, which is pretty relevant context to answer this question, along with a result that's accurate. Like, yes, Vectorize supports SingleStore, and and here's why. Here's where I found this information. And then once you're happy with this, you can come in here. We've got we've got now a retrieval endpoint. So the retrieval endpoint has built into it re-ranking. It has built into it vectorization of your input. So instead of your application taking the user's, the question the user asked, going off, creating a vector of that, going to your vector database, doing an ANN search, you just make a simple API call here. Keeps your application architecture a little bit simpler. And then you get the built-in re-ranking, which gives you things like relevancy, so you can cut out things and filter out things that aren't really relevant to the user's request, save yourself some tokens, keep the LLM from getting confused, thinking that it's supposed to use the irrelevant context that made its way back from the vector database somehow. And so let me pause here. Pavan, I think this is kind of a good place to maybe stop. I think this is a good overview.
Yeah.
I know you've been doing a lot with this, so I'll let you maybe be a
Yeah.
proxy for some of the questions that people maybe in our
Yeah.
audience have.
Yeah. Let me see if we have some questions. Yeah, there are a couple of questions, but yeah, amazing to see how Vectorize is helping companies build production-ready RAG pipelines. So we have this question here. So Deepak Roy is asking, which frameworks or models you suggest for analyzing financial documents, accounts related?
Yeah, I'd say the best ones that I've seen for that so far are from a company called Voyage AI. And so Voyage has built domain-specific embedding models. One of those, I'm almost positive, but let me double check before I say this for sure. They have the Voyage AI Finance 2 model. And so the Voyage AI Finance 2 model is one that I would start with and kind of try
Mhm.
out. And again, you could use the RAG evaluation feature to run a sample of those financial documents, Deepak, through a RAG evaluation. You could try the Voyage finance model. You could compare that against some of the OpenAI models, against I think there's a Mistral model in there too. And then you can see how the results work for you. Do you actually get back better results and get some data to kind of back that decision for you?
Cool. So there is one more from Pavan Srinivas. Can we use RAG pipelines without code, like with agent instructions?
RAG pipelines without code. So everything you saw here in the RAG pipelines side really didn't have any code associated with it. Now we're working on an API for those of you in the audience who do want code and you want to do infrastructure as code. We're working on that. We think that's actually a really important feature that we'll work with. But if you are somebody who's maybe a little less technical, you need to populate a search index, and you just want to build a RAG pipeline, you can absolutely do that with just what you saw here. Without writing a single line of code. You can play around with your index in that RAG sandbox. And so you can push the data in, and you can have a little chat interface with it right there. Now, obviously, that's not good if you want to release the application out to like your users. You want it to be branded with your company's name. But we do have some GitHub repositories that make that process of building. We give you a really nice starting interface for like a streaming chat, streaming chat application. So not entirely no code. Like we're not a no code platform. We're a platform that's really built for developers who want to get stuff done and they don't want to spend a lot of time dealing with all the problems that could come up with data engineering. They just want to get their data so they can build the application. That's really what Vectorize is aimed to do. But there are some cases where if you say, hey, look, I just want to have a simple chat interface on top of these docs or on top of this, all the contents of my Google Drive, it becomes pretty easy to do that, even if you're somebody who's not super technical.
Cool. So we have one more here from Lomo. If you are making an API request to a database and pass the results to the model, then formulate the response and send to user, do we need RAG for that use case? This is a tabular data and it is dynamic, always changing.
By virtue of the fact that you're doing, you're querying the database, that by my definition, and you can have your own definition that differs from mine if you want, but for my definition, that is RAG. That is a retrieval step. I'm going to go try to retrieve the context. Now, do you need RAG with a vector database? Not always. I think where a vector database becomes the most useful is when you have unstructured data that you either want to do semantic search on top of, or where you want to take that unstructured data and retrieve, almost turn it into semi-structured or structured data by metadata extraction. So I think there are some cases there for both, but I would say, Lomo, just by the virtue of the fact that you are doing a database lookup, to me, that is a type of RAG. So I would say, yes, you would need RAG. If you don't like my semantics, you're free to use your own, though.
And there's one last one by James, Anthony James, how to use RAG for Excel files or tables.
Yeah, so using those is there's some trickiness to Excel files and tables. So there's like tables within a PDF. I think the world at large is getting better at dealing with this. The way that we envision you using spreadsheets today. So you can just drop the spreadsheets into your RAG pipeline. And so what I would recommend that you do, Anthony, is just to say, like, let's give it a shot. If you have a bunch of CSVs or Excel files, whatever they may be, drop those into your RAG pipeline and see what results you get. Now, where I expect this to go and how I expect this to work in the future is that only certain columns within a spreadsheet do you really want to vectorize and do you want to do semantic search on. Now, I view the columns as sort of coming in a few different flavors. Either they should be metadata, and so like maybe column A and C and D are metadata, and I want you to take the first row and I want you to sort of like use that as the key and use the value in the cell below as the value. And so you'd have like customer ID equals customer ID, or first name equals whatever first name, things like that. And then if you had some sort of like maybe notes in a column where you'd say, hey, that's the chunk, that's the thing I actually want you to send into the embedding model, that's the thing I want you to vectorize. Right now, what you'll get is that you will basically get a set of rows that will come back and be treated like text, and that text will get vectorized, and it will work probably better than you think it would work, but it won't work perfectly. That's kind of the best way I could say that.
Cool, cool. So, yeah, I mean, all the questions are done. I think those are the questions. Thanks, Chris.
Yeah.
I really enjoyed talking with you, and thanks for showing us how to build production-ready React pipelines. I would really recommend everyone who is watching this go to vectorize.io, create your account, reshared account, and also go to singlestore.com, use SingleStore as your vector database. It's a complete end-to-end data platform to use. You can also use it as a vector database, connect your vector database and start using Vectorize and uh, do all the experiments and start building your production ready rack pipelines in minutes, like how Chris showed. So yeah, Chris, I mean, where can people connect with you if On LinkedIn? Are you
Yeah,
active on LinkedIn?
yep. Yeah, I'm on LinkedIn. Chris Latimer, all one word. I forget I think it's LinkedIn/in/Chris Latimer.
Yeah,
If you just look
yeah.
for Chris Latimer, you'll see my ugly mug smiling at you on my profile picture, and follow me. Send me a connection request, whatever you prefer, and also follow Vectorize, Vectorize.io, all one word, I believe, on LinkedIn. We're putting out a lot of really just a lot of great things about RAG. If you're interested in this topic, I'd say right now go look up Vectorize.io. You'll find our little V icon on there. Follow us. You'll see, take a look at the page. You'll see there's a lot of great stuff on RAG. It's not just your typical software vendor like just pushing out stuff that's self-promotional. We try to put out things that we think people are going to be really interested in. So follow that for a lot of great information. Reach out to me anytime, and then Vectorize.io to go create your account and start playing around with stuff.
Cool. Yeah. Thanks for joining us today, guys. I mean, this was really nice. Thanks, Chris.
Yeah,
We'll meet next time and we can do more such sessions.
sounds
Thanks.
good. Thanks, everybody. Thanks, Pavan, for having
Good
me.
day. Bye bye.
All right, take care.
Thanks.
Bye.
Thanks. Bye bye. Bye. Bye.